Hi, my name is Adam Langlois, and today I'm going to be showing you how to set up our senior design device. So, the first thing you'll notice on this control shaft is that we have a permanently installed component. This is referred to as the buffer, and eventually the swing down arm from the carriage is going to mount to it. However, there are a couple of steps that we need to cover first. The first part that we need to install onto the shaft is this shaft lock. It serves the purpose of making sure that the control shaft remains static and it keeps it from bending because there's a pivot in the middle right there. Next thing that we're going to do is install these pulleys onto the control shaft knobs, like that. You then slide the carriage into place right here, and you pull the belts under the pulleys, like this. It's kind of tricky. You have to slide them over and make sure that you put the right pulley, or the right belt on the correct pulley. But once you get it like this, you are set. So that's how you set that up. The next step is to bring down the spacer arm. That'll lock right there, and you can see it holds the carriage rigid to the control shaft. There's a connector that goes right here, and there's screws that just pop in like such. With the other screw go. Like that. And then last but not least, these tensioner arms, you're going to swing them into place. There's a wing nut on the bottom that you spin to tension them. So now those are locked in place. You can see the belts are tensioned. And then this pivot has a second screw in the back. You just slide the screw through, it comes out right there, and that locks with a thumb nut. So that's all the steps to setting up the device. You're then able to grab the controller and you can move it around however you want. As you can see in the middle right here, we have a toggle switch which alternates the color of an RGB LED that indicates the magnification. Since we're looking at 20x right now, we'll go ahead and set it to blue, which is the color for the 20x magnification, and then we can use the right D-pad for incremental movement. If I hit right, you'll see it'll shift over an entire frame. Similarly, if I hit down, you see it'll bring us all the way down to a new frame on the y-axis. If there is an issue with incremental movement, we've incorporated the left D-pad for continuous movement. So as long as I hold the up button, I can bring it back up, I can bring it to the left, I can bring it to the right, and I can also bring it down just by holding that. This allows us to fix small errors that we make.
This is a time-lapse demonstration using our device at the 20x magnification. As you can see, the incremental movement allows for a full frame change of the array. The continuous buttons are used for when errors occur. For testing, we completed imaging of the array at each magnification, once manually and twice with our device. The results showed that our device allows for a percentage decrease of time for imaging at all magnifications. The data obtained from our device are averaged together to calculate the percent decrease of time, resulting in about a 13% time decrease at 5x magnification, 48% time decrease at 10x magnification, 59% time decrease at 20x magnification, and 60% decrease at 40x magnification. During testing, we found that without the device, imaging became more complex the higher the magnification. We hope this device allows for easier imaging at all magnifications. This concludes our demonstration of our device, and we hope that this becomes very useful in the lab.